Hi, in this session we will discuss about embeddings. So, embeddings are the backbone of any AI system, like either you are developing a retrieval-augmented generation system or any application. If you are developing on top of AI, you should know about embeddings. So, embeddings are the backbone for LLMs or generative AI. So we see the definitions are embeddings are semantic backbone of LLMs. They get at which raw text is transformed into high-dimensional vectors of numbers that are understandable by the model. When you prompt the LLM to help you get answers from, your words or tokens are transformed into an high-dimensional vector space, where semantic relationships becomes a mathematical relationship. So your text or anything in the form of vectors, if you represent that one will be easily understandable by the LLM. So that is the main premise here, why we convert uh, words or text into embeddings. So next, what makes a good embedding? Because based upon that is a basic foundation where you build a AI system on top of that when in order to get answers or make a good AI system based upon your own data. So now, what makes it good? So when it comes to LLMs, embeddings can be a sort of dictionary of their own language. Each LLM model will have their own vocabulary and then their own way of how to do the embeddings. So, for example, if you are using OpenAI, then you have to use the same OpenAI compatible OpenAI model in order to retrieve the data and do the work. For example, if you are doing something on a different model and you are using OpenAI model to generate the answer, if you are using a different model for embedding and if you are using OpenAI for getting the answers, it won't work. So both should be compatible such that the embedding is being done and then from there you can retrieve. Okay. So so better embeddings allow these models to understand the human language and communicate with us, which makes what makes embedding good. In other words, what makes embedding model a good embedding model in order to achieve the required results. One is semantic representation. So the semantic representation is the how similar the words are represented. So that is the main goal. Like if you have a good semantic representation of the model, then you can easily achieve the required results. So previously we discussed if you have a specially fine-tuned finance model, if you're working in a finance domain, then that will easily understand or semantically correlate the user context or the question to the vocabulary it has its own, so that you can get the better answers. So that is the main point here. And then dimensionality. So dimensionality, we know, like 2D, 3D and all. So these vectors have multiple dimensions, like starting from hundreds to even thousands. So if you have more dimensions, you will get more representation, but obviously you will have you should store the data in a physical database, so then it will require more space, and also sometimes it will be overfitting such that you may not get the required results. So you should do the apt decision, which embedding model you are going to use based upon your own business outcomes. So in this example, I have taken text embedding 3 small, which is from OpenAI. It has 512 dimensions. I will show you the output how it looks. So this is just for displaying the content. I'm using a dark theme here. So now this is the actual embedding what I'm doing. So what is the sentence I'm doing here? So I am just I do want to embed this entire sentence. Okay. So here you can see this is related to finance. What is finance and what it does. So it is encapsulated in a sentence. So now this sentence I need to convert into tokens, and the tokens will be passed to OpenAI, and then OpenAI will do embeddings and then return back the embeddings, so that I can store it anywhere, either in a vector database or in memory database, like whatever maybe. So this is the process. So this is a sentence, and we need an OpenAI key. So this is a way how we can pass OpenAI key which is stored in secrets in Collab. So I'm using text embedding 3 small. You can get the details about what is that and how it the specifications of those things. This is comparatively cheaper, and then see, for 1 million tokens, that's a price. So here I give a small description about OpenAI embedding model. Text embedding 3 small, creator is OpenAI. You can go through these things. So the main highlight here is that we are using this one, and it has 512 dimensions. So suitable for memory and storage constrained environments. So I think this is more than enough for our use case. If you need more, then you can go for a bigger embedding model which has more dimensions. So these are the technical details. You can go through these things compared to previous models. So now how we can use this. So we are going to pass the particular sentence or a block of sentence to OpenAI API endpoint, and then we will specify what embedding model we are using, and then we are sending the content, and the OpenAI will do the embeddings and return the embeddings of that particular sentence, so that we can store it in our vector database. So I passed the particular sentence. This is the first sentence variable where I have this particular paragraph, or we can say small paragraph. So this is the actual embeddings for that particular content, generated by text embedding 3 small. So keep in mind, if you are using OpenAI embedding model, make sure you are using OpenAI embedding model for generating the answers as well. So these are compatible. If you are using a different model and it is not compatible with OpenAI, so definitely your system will fail. So that is one thing you need to keep in mind. Yeah, so these are the embeddings. Thank you.